And good morning.
Morning.
The following Zoom session is being recorded. Thank you for that.
Good morning.
And will appear later on my YouTube channel, Math with Mayo. When you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. So we're going to start off with questions from section 9.1, and then eventually today we'll get to 9.2. So are there any questions from section 9.1?
No, I don't have any.
None for Greg. How about Diana?
Neither do I. Thank you.
Okay, on to 9.2. All right, so the big deal today is we're going to learn how to go back and forth between radicals and exponential expressions. Okay, and what it amounts to is this. When you have an index, okay, of a radical, you can write that same expression using a fraction exponent. The index of the radical becomes a denominator of the exponent. So the cube root of 8 is equal to 8 to the 1/3 power. Furthermore, if we had the cube root of 8 squared, that would be 8 to the, oops, not 3, I did that wrong, sorry, to the 2/3 power. So the exponent is still on top, the index becomes the denominator. Okay, any questions yet? Let's take this problem. Okay, so the cube root of 8 squared. What is 8 squared?
64.
And what is the cube root of 64?
Is it 4?
It is. Okay, so the cube root of 8 squared is 4. Now let's take the cube root of 8 squared. What's the cube root of 8? The cube root of 8.
2.
Right? So this would be 2 squared, which is 4. So in this case, we could do the exponent and then the root, or the root and then the exponent. Okay? As long as they're both real, we can do them in either order. Typically, it's easier to take the root first and tear something down and then build it up rather than build it up and then tear it down, kind of thing. Now, let's go back to this. 8 to the 2/3 power is equal to 8 to the 1/3 power squared is equal to 8 squared to the 1/3 power. In other words, I can pull it apart. This would equal that, and this would equal that. So likewise, I can do it either way. Here I'd be doing the root and then the power. Here I'd be doing the power and then the root. And as long as they're both real, you can do it in either order. Okay. Let's go back. In fact, let's do this. We determined that 8 to the 2/3 power was equal to 4, right? So let's do 8 to the 2/3 power on our calculator. Now, we need to be careful. First of all, I'm going to show you the wrong way to do it. And then I'm going to show you the right way to do it. In other words, you've got to quantify the exponent. If you go 8 raised to the 2nd power divided by 3, that's basically 64 divided by 3. You need to tell the calculator that the 2/3 is the exponent. So you're going to go 8 and then the little caret power key parentheses 2 divided by 3 equals, and that should give you an answer of 4. If you do it incorrectly, you get an answer of like, what is that, 21 and something or whatever, okay? All right, now let's review the rules or properties of exponents. These were back in chapter 5, which we didn't cover this quarter. If you took Math 85 from YBC here, you covered it. If you didn't, you may have covered it in a high school algebra class. Maybe it's been a while, but let's take a look at the rules. All right. If you're multiplying two powers with the same base, you add the exponents. Example, x cubed times x squared oops, let's try that again. X cubed times x squared would be x to the 5th power. Okay. If you're dividing two powers with the same base, you subtract the bottom exponent from the top exponent and attach it to the common base. So if I had x to the 7th divided by x to the 3rd, that would be x to the 7 minus, man, I'm got to slow down here. 7 minus 3, which is x to the 4th. Okay. Let's say you've got a product raised to a power. You attach the outside exponent to each factor inside. So if I've got 3x to the 4th power, that's 3 to the 4th power, 4x to the 4th power, which is 81x to the 4th power. If you have a quotient raised to a power, you attach the outside power to both the numerator and denominator. So if I've got 3 over x squared, that's 3 squared over x squared, or 9 over x squared. Okay. And now for some more rules. Let's see, what have I left out? Quotient. If you have a to the 1 power, that's the same as a. If you have something to the 0 power, that's just plain old number 1. If you have a base raised to a negative exponent, that's 1 over that base raised to a positive exponent. If you have a fraction raised to a negative exponent, that's the reciprocal, raised to a positive exponent. If you have 1 over a base to a negative exponent, you can move that to the top and make the exponent positive. Okay. I think I reviewed all the rules. We'll find out here. So now what we're going to be doing is using these rules, but now we can deal with exponents that are fractions. Okay. Let's see. Put on my glasses so I can see. 625 to the 1/4 power. So that's the equivalent of the 4th root of 625. So what would the 4th root of 625 equal? Tell you what, let's find it on our calculator.
It's 5.
5? Okay, we're good. Do you want to do it on the calculator or just keep going?
I did it on the calculator, how you explained it to us.
Okay, so you could either do this, or you could do that idea where you put the index in and then use the x root. In other words, you could do it here or you could do it there. Okay, good. What about this? 1/16 to the 1/2 power. So that would be 1 to the 1/2 power over 16 to the 1/2 power. The 1/2 power, that's the same as what root?
Would it be 2?
Yeah, so the square root. Okay, what's the square root of 1?
1,
What's the square root of 16?
4.
Right, so there's your answer. Okay. All right, here, 25a to the 8th to the 1/2 power, it says, simplify each expression, assume that the variables can be any real number, and use absolute value symbols when necessary. Okay, all right, so we're taking the square root. So that means we have to take square roots of only positive or 0 numbers, right? We can't take the square root of a negative number. Let's see. We've got a product raised to a power. So this would be 25 to the 1/2 power, a to the 8th to the 1/2 power. What is 25 to the 1/2 power?
Would it be 5?
Right.
5.
I just thought of a rule that I didn't cover. If you have a power raised to a power, you multiply the exponents, because that's what's going on right here. So a to the 8th to the 1/2 power would be a to the 8 times 1/2, which is 8 times 1/2, which is,
4.
there you go. Okay. You just wanted to leave me hanging there, didn't you? Yeah. All right. Let's see here. How about this? Let's see. X cubed to the 1/3 power. What would that be?
Would that be x to the 9th? These are multiplying the exponents.
Okay.
Would it be just x?
There you go. Because it'd be x to the 3/3 or x to the 1 or just x, right? Okay. Yeah. That's just going to be 1. So you're going to get x to the 3/3, which is x to the 1, which is x. So you can just go straight there. Okay. What about this one? Oops. -16 q to the 4th power, all to the 1/2 power. Can you take a square root of a negative number?
No.
No.
Because you take -16 to the 1/2 power, so it's not real. See that?
Yes.
Okay. Let's see here. 27 to the 2/3 power. So that's equal to 27 to the 1/3 power squared, because I could do the index and then the exponent. Okay, or take the root and then the power, I guess I should say. What's the cube root of 27?
3,
And what's 3 squared?
9.
So 27 to the 2/3 power is 9. Now be careful. You're not taking 27 times 2/3. You're taking 27 squared and cube rooted, or cube rooted and squared. Okay. Just be careful with that. All right. Let's see here. How about this? 27 a cubed b cubed all to the 2/3 power. It says simplify each expression. All variables represent positive real numbers. So this would be 27 to the 2/3 times a cubed to the 2/3 times b cubed to the 2/3, which would be, all right, 27 to the cube root squared, a to the 2nd, b to the 2nd. Now, why did I do what I did? I took this and broke it apart so I could do the root and then the power. And here, what's 3 times 2/3? 2. What's 3 times 2/3? 2. You see what I did there?
So how did you, for the 27 1/3 parentheses squared?
I'm not done.
Oh, okay. I was so
Yeah.
confused. Okay.
No, sorry. Okay, so what is 27 to the 1/3 power?
3,
Okay, and what is 3 squared?
9.
There you go. Yeah, I wasn't done yet. Sorry, didn't mean to.
No, it's fine. I was just confused.
Yeah, I was just saying, okay, I'm just kind of doing one step on each thing at a time. So this, I broke it apart so I could simplify it further. This, I can't solve for A, but I can simplify the exponents. All right. Let's see here. 1/16 x to the 8th, y to the 4th, all to the 3/4 power. So that becomes 1 to the 3/4 power over 16 to the 3/4 power times x to the 8th to the 3/4 power times y to the 4th to the 3/4 power. Okay, because if you have a product or a quotient raised to a power, you attach the power to each factor in the numerator and each factor in the denominator. We okay with that?
Yes.
All right, so let's take this one thing at a time. 1 to the 3/4 power. Well, what's the 4th root of 1? It's just 1.
Would it be 1?
Yeah, what's 1 cubed?
1.
1.
So this is going to be 1. Okay, let's take a look at 16 to the 3/4 power. Well, 16 to the 3/4 power, we could do the 4th power, 1/4 power, and then the cube. What's the 4th root of 16?
2.
What's 2 cubed?
Would it be 8?
Yeah, so 16 to the 3/4 power is 8. Okay, because the 4th root of it is 2, and 2 cubed is 8. You okay?
Now, what if I were to do it? Would it still work if I did 16 in the calculator? 16 caret parentheses 3 divided by 4? Or does that not apply?
Yes, it does. Try it. See what you get. You should get 8.
Yes, it worked.
There you go. All righty. In fact, you could even do this. You could go 16 to the 0.75. Where'd I get that? 3 divided by 4? Okay. Good, 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 good. Let's clear those. So now let's deal with that. Well, what's 8 times 3/4? Couldn't I reduce this down and get 6? 8 times 3/4.
Yes.
Same thing here. 4 times 3/4 could reduce down to y to the
3rd.
third. So there's your answer. 1/8 x to the 6th y cubed, or you could write it as x to the 6th y cubed all over 8. Let's see what they did. I'm just curious. They wrote it this way, but this way would also be correct. All right. Now, it says, change each radical to an exponential expression. So the 7th root of 7p squared q becomes 7p squared q to the 1 7th power. So the index becomes the exponent on, becomes the denominator on the exponent. Okay. Same thing, this would be to the 1/2 power. You okay there?
Yes.
Right? Now we're going to go the other direction. Write each exponential expression as a radical expression. So this would be the 5th root of 7a squared b squared. All right, simplify each expression. All variables represent positive real numbers. So 49 to the negative 1/2 becomes 1 over 49 to the 1/2, which is 1 over, what's the square root of 49?
7.
7. Again, recall the way to get rid of a negative exponent. You move the base to the other side of the fraction bar. 8 to the negative 1/3 power would be 1 over 8 to the 1/3 power, which is 1 over the cube root of 8 is 2. (25/49) to the negative 3/2 power would be 49/25 to the positive 3/2 power, reciprocal of the base. Change the sign of the exponent, which would be 49 to the 3/2 over 25 to the 3/2. Quotient raised to a power, attach the power to each, the numerator and the denominator of the quotient. Now I'm going to take this and I'm going to break it apart and I'm going to do the root and then the exponent. What's the square root of 49?
7.
And 7 cubed, let's see here. 7 cubed is,
343.
you're quicker than me. Good job. All right. And then let's do the denominator. So this would be 25 to the 1/2 to the 3rd. What's the square root of 25?
5.
And 5 cubed is 125. But the first thing we want to do is get rid of that negative exponent. And by the way, you can't have a negative index. So let's say you had this problem, 7 to the negative 1/3 power, and it said change this to radical notation. It would not be that, okay? What you'd have to do is rewrite it like this, and then it would become that. Okay, so you can't have a negative index. We just don't go there. You have to do that reciprocal to get rid of it first. Okay. Let's see here. 4 to the 2/5 power times 4 to the 2/5 power. It says simplify each expression. Write the answers without negative exponents. All variables represent positive real numbers. So we're multiplying 2 powers with the same base. So we're going to add the exponent. So this would be 4 to the 2/5 plus 2/5 power, which is 4 to the 4/5 power. Okay. Let's see. 5 to the 1/3 power times 5 to the negative 5/3 power. So that would be 5 to the 1/3 minus, well, plus a negative, okay? But plus a negative would be the same thing as 5 to the 1/3 minus 5/3 power, which is 5 to the negative 4/3 power, which is 1 over 5 to the positive 4/3 power. Did you follow all that? So I added the exponents. and then moved it downstairs to make the exponent positive. And the 5 to the 4/3 power is not a nice number, so I'm not simplifying it. I'm not doing any calculator decimal approximations at this point. All right. Let's see here. How about this one? B to the 3/5 times b to the 2/5 all to the 8th power. Well, inside you'd have b to the 3/5 plus 2/5, which is b to the 5/5, which is b to the 1, which is b, and then you'd end up with just b to the 8th power. Now, you could go straight here if you can see that. You don't have to do every little teeny step, but I'm just showing you how I got there. All righty. Let's take a look at this. 2 to the 5/6 power times 2 to the 1/3 power over 2 to the 1/2 power. Multiplying powers with the same base, you add the exponents. So I need to take 5/6 plus 1/3. Well, to add 5/6 plus 1/3, I need a common denominator of a 6. So I've got to change the 1/3 to 2/6, which gives me 7/6. So my numerator, 5/6 plus 1/3 is 5/6 plus 2/6 is 7/6. So my exponent in the numerator is 7/6. Haven't done anything to the denominator yet. How are we doing? Still okay?
I'm still okay.
All right. Greg, still with us? Still.
Yeah, I'm still with you guys.
Okay. Now, dividing two powers, you're going to subtract the bottom exponent from the top exponent. So let's see, 7/6 minus 1/2 would be 7/6 minus 3/6, which is 4/6, which is 2/3. So this becomes 2 to the 2/3 power after all that. Ready? Y to the 2/5 power times the quantity y to the negative 2/5 plus y to the 3/5. Again, all variables represent positive real numbers. We're going to distribute. So we're going to get y to the 2/5 times y to the negative 2/5 plus y to the 2/5 times y to the 3/5. Multiplying two powers with the same base, you add the exponents. So this is y to the 2/5 plus negative 2/5, which would be y to the 0 power, which is 1. This would be y to the 2/5 plus 3/5, which is y to the 5/5, which is y to the 1. So we end up with just y plus 1, or 1 plus y. So we're just getting used to those rules again, but using fractional exponents. Okay. Use rational exponents to simplify each radical. What they want you to do, we're going to take this radical, we're going to change it into exponential form. We're going to simplify it, and then we're going to change it back into radical form. Ultimately, when you're comfortable with it, you could go straight here, because what's 3 divided by 6?
2.
3 divided by 6 would actually be,
Oh, no, 6 divided by 3 is 2. I'm sorry.
right. So 3 divided by 6 would be a half. Therefore, this would be a 2. You follow what I'm saying? In other words, you could reduce that
Yeah.
down to the 3 over 6, 1 over 2 kind of thing. And if that's confusing you, forget I even said it and just go that way until you're comfortable with it. Okay. All right. How about this? The 12th root of 13 to the 4th power. So that would be 13 to the 4/12 power, which is 13 to the 1/3 power, which is the cube root of 13. How about this one? The 6th root of x squared y squared. Well, that would be x squared y squared to the 1/6 power, which would be x squared to the 1/6, y squared to the 1/6, which would be x to the 1/3, y to the 1/3, which would be the cube root of xy. All right with that?
Yes.
Okay, how about this one? The 4th root of the square root of x. Well, that would be the square root of x to the 1/4 power, which would be x to the 1/2 to the 1/4 power, which would be x to the 1/8, which would be the 8th root of x. Let's go back through that a little bit slower. Okay. So this first step, I took this outside radical. The index of a 4 became an exponent of a 1/4. Then on the inside, this index of a 2 became an exponent of a 1/2. But a power raised to a power, you multiply the exponents. 1/2 times 1/4, you multiply straight across and get 1/8. But converting it back, that becomes the 8th root of x. All righty. Let's see here. How are we doing? Negative 27 x cubed to the 1/3 power. It says, simplify each expression. All variables represent positive real numbers. So this becomes negative 27 to the 1/3, x cubed to the 1/3. What's the cube root of negative 27?
-3.
Good. What's the cube root of x cubed? Or what's x to the 3 times 1/3 power, x to the 3rd over 3, x to, oh, it's just x, isn't it? Okay with that?
Yes.
Yeah.
All right. Let's see here. 16a to the 4th to the negative 1/2 power. So that would be 1 over 16a to the 4th, the whole thing to the positive 1/2 power, which is 1 over 16 to the 1/2 power, a to the 4th to the 1/2 power, which is 1 over, what's 16 to the 1/2 power? What's the square root of 16?
4.
Yeah, same thing as 1/2 power, right? You got to get used to that. A to the 4th to the 1/2 would be a to the, what's 4 times 1/2?
Would it be a squared?
Yep, good. Apparently these two don't get along very well. Let's move them closer together. There we go. All right. How about this one? Negative x to the 4th to the 1/4 power.
Is that no solution?
Good job. It's not real because you're taking an even root. Okay, now let's go through this. X, if X is positive or negative, when you raise it to the fourth power, it's going to be positive. But if you put a negative sign in front of a positive, then this whole thing's going to be negative. So you're taking a fourth root, you're taking an even root of a negative number, no can do. All right? Does your brain hurt? Okay. Nobody answered that one, huh? All right. How about the ninth root of 8x to the sixth? So that would be 8x to the sixth to the 1/9 power, which is 8 to the 1/9 x to the sixth to the 1/9, which is 8 to the 1/9 x to the 6/9, which is 8 to the 1/9 x to the 2/3. But there's something else we can do that you might not think of, okay? 8 could be written as 2 cubed. Okay, so 8 to the 1/9 becomes 2 cubed to the 1/9, but now that's 2 to the 3/9, which is 2 to the 1/3 x to the 2/3. And if that wasn't tricky enough, now I'm going to rewrite it as 2 to the 1/3 x squared to the 1/3 so that I can pull an index of a 3 out. Because I have to have a common index to be able to write it in this form. How are we doing now? Lot to swallow there.
Yeah, so how would
Yeah.
you I see where you got the 2 cubed to the
Okay.
1/9, but how do we know when we are supposed to or did you just know that right off the bat?
The reason that you would know it would be, can you take the base and write it as something raised to an exponent? Okay, so
Okay.
like if it had been 7 to the 1/9, I'd be like, oh, I can't do anything with 7. But I can break 8 down into 2 cubed, or let's say you had 25 to the 1/5. That would be 5 squared to the 1/5, or 5 to the 2/5. Because, oh, I can break that down and write it as something to an exponent power kind of thing.
Okay, I see.
That's the trick to look for. And again, it's one of those things where, you know, the first couple times you see it, it's like, what? But it just, you sort of end up getting used to it and adding it to your bag of tricks. Let's see if I can find another one. Actually, let's do this. Okay, I'm going to do this maybe the conventional way. Oops, it helps if you write the right numbers. Okay, the fourth root of 81 is 3. Okay, here's another way I could do it. I could say, well, that is 3 to the 4th power. So now I've got 3 to the -1 power, which is 1 over 3 to the 1, which is 1/3. So that's kind of using that same idea that I just used. In this case, I didn't have to, but I certainly could do that. You see what I did there?
Yeah, I see.
Diana, are you seeing it?
I see it. It's just my brain takes a little bit longer for that.
Sure, sure. That's okay. I know you got to kind of get used to it there. I think I've tortured you enough for one day. So I am going to stop the recording.